Hello and welcome to Vodcast 5.1. Chapter 5's focus is plate tectonics, and in Vodcast 5.1, we will overview continental drift. This is a really important podcast because it emphasizes the nature of science. At the heart of all scientific theories, laws, concepts, and information is evidence. Scientific claims and anything that you affix the term science to is meaningless if there isn't evidence to support it. A great deal of scientific evidence comes about through experimentation and observation. Up to this point in the course, we focused a lot on how Earth's surface is changing. And a logical question to ask at this point might be, have the continents always been where they currently are? In the early 20th century, the scientific consensus was the continents didn't move. But now let me introduce a very important name that you should know, Alfred Wegener. Alfred Wegener was the first to argue forcefully that the continents did move, and he argued for the idea of continental drift in the early portion of the 20th century. Let's start off by considering some of the evidence that supported his idea. The first piece of evidence is something that even young children can intuitively see, and that's the jigsaw puzzle fit of South America and Africa. If you look at a current map of the world, and then you focus on the east portion of the South American coast and the west portion of the African coast, it seems pretty plausible that they could possibly fit together. So perhaps at one time, far back in Earth's past, they actually did. Now let's consider some evidence that actually supports that particular idea. We find the exact same dinosaur fossils on the east coast of South America as we do on the west coast of Africa. The dinosaur species I'd like to focus on is the Mezzo Saurus, which is shown in this center picture. If we assume that Earth's continents don't move, there is zero chance that you would find the same dinosaur species on the east coast of South America and the west coast of Africa, because no dinosaur species could swim the distance between South America and Africa as they currently are. Our focus has been on the Mesosaurus, but there are multiple examples of fossil match across the seas. There are also two other evidences for continental drift that we will consider in this podcast, namely rock types and geological features, as well as ancient climates, and we'll look at those on the slides that follow. Let's take a look at the geological evidence for continental drift. This probably isn't an earth-shattering observation, but the Appalachian Mountains run along the east coast of the United States and into Canada. But what's really interesting is if you take a look at the mountain ranges that run the west coast of Europe and the west coast of Africa, as well as the east coast of Greenland, you can imagine squishing these continents back together across the Atlantic Ocean, and all of those mountain ranges would merge and match up very nicely. Long ago in Earth's history, the mountain building mechanisms that were occurring to form the mountains shown on this image likely occurred while all of the land masses shown were very, very close together. The final piece of evidence that we'll consider that supports the theory of continental drift is climate evidence. In this video, we've considered four primary evidences that support the theory of continental drift. There are many more than the four that we've overviewed, and in future vodcasts, I will overview some of the additional evidence sources that we can consider. But for now, let's take a look at this climate evidence because it's extremely compelling. Start off by taking a look at the world map as it currently exists. Let's focus on coal swamps to start. We find coal swamps along the east coast of the United States, in Europe and northern Africa, as well as in southeastern Asia. Now for coal swamps to have formed, you really need to have a hot, humid climate. But the current location of those coal swamps is very far north of the equator. So the coal swamp locations as they currently exist don't seem to really make sense. But let's take a look at the continental drift model shown in picture B. If we reconstruct the continents as they probably existed long ago, we squish North America, South America, and Africa very close together. And then notice the position of Europe and Southeast Asia. What's really important to notice is that when we rewind Earth's history, all of the coal swamps occur at or extremely close to the equator, as they should, because coal swamps must have hot, humid conditions in order to form. Okay, if you don't mind me bouncing around, I'm going to now go back to picture A. The other really important piece of evidence from a climate perspective that supports the theory of continental drift is glacial ice. As mentioned in a Vodcast last chapter, Antarctica is the world's largest ice sheet. But what's really interesting is we find evidence of glaciation on the southeast coast of South America, in a huge portion of southern Africa, in the southern portions of India, and also in southern Australia. But let's take a look at picture B, because the glaciation shown in image A can be explained if we rewind Earth's history and look at where the land masses were long ago. We already know the coal swamps exist very close to the equator, as they should for their formation, but all the regions that had glaciation in image A would have been situated very, very close to what's currently our South Pole, and glaciers would have no problem extending into South America, Africa, India, and Australia, as shown in image B. So all of the evidence outlined in this vodcast, when taken collectively, builds an extremely strong case for continental drift. But keep in mind, the one thing that Wegener had working against him was that he couldn't provide a mechanism for how the continents moved. It's one thing to say they moved, and then to provide compelling evidence that they may well have, but it's another thing entirely to explain the process by which they did move. In our next vodcast, I will present that mechanism that explains how the continents move. Okay, that concludes this video podcast, and at this point we are going to turn our attention to plate tectonics.